welcome to everybody this afternoon in Hong Kong. And I really want to thank the Hong Kong Industry Council for this invitation and also accommodating my tight schedule. I'm actually flying off to Spain to attend the Mobile World Congress next week. So I appreciate the accommodation. I'm Kailash Narayanan. I'm the Vice President and General Manager of the Wireless Devices Business Segment at Keysight Technology. So all of the major wireless vendors are part of my customer base. Today, what I want to talk about is this new revolution called IoT, which I think is pretty much going to influence and dictate how business is done and how value gets delivered in many vertical industries going forward. So this is almost like how the IC revolution happened in the 1960s and 70s, how the internet revolutionized things back in the late 90s. So it's one of those things, right? So we're upon a major industry phenomenon, and there are lots of challenges that need to be overcome. My objective here is to provide an overview of those challenges, talk about how Keysight can help, and answer a few questions. Okay. So a brief introduction on Keysight. We're originally part of the Hewlett-Packard Company. Many people say Hewlett-Packard Company created Silicon Valley, and we're proud to be part of that heritage. Our value is to provide breakthrough solutions, performance and cost-wise, and we do that in multiple vertical industries. So we cater to the testing challenges in wireline industries, wireless industries, devices, cloud, and we also have a big presence in aerospace defense. So that's Keysight, and it's providing solutions for different phases of the product life cycle, all the way from simulation through early design, pilot manufacturing, and high volume manufacturing. So that's just a brief introduction on Keysight, what we do. Okay, it's difficult to start IoT without talking about because we really get into the details of device regulations and testing, but we'll have to kind of step up and see what the big landscape is. And this audience here is going to influence this landscape. You all are in influential positions, and you're going to be playing a major role in shaping this industry. So let's kind of take a look at the big picture and then go into challenges associated with IoT devices. So the bottom line is IoT, like I said, it's revolutionizing the industry. Every company is organizing itself differently to add connectivity to their devices. You're going to have growth in smartphones and laptops and tablets and so forth, but I call those traditional devices. This is the new generation of devices, right? All of the growth of the electronics industry is mostly linked to IoT. There will be growth in smartphones and tablets and laptops and so forth, but most of the growth is going to come from the IoT devices. The reason is this. When you think about a laptop or a tablet or a smartphone, it's really about personal productivity, right? You use a smartphone to talk, to check email, to surf the internet, do some online shopping, listen to music, things like that. Ultimately, it's about how a person can be productive. But IoT is not about that. It's really making an enterprise productive. So we're shifting from personal productivity to enterprise productivity, right? So it's helping businesses. That's why it's such a big deal. If smartphones and tablets were such a big revolution, you can imagine if IoT is going to help businesses create value, how big this will become in multiple vertical industries. So whether you're a chipset maker or a device maker, an OEM, contract manufacturer, an end-to-end player, a consulting company, it doesn't matter. There is value that you can generate and deliver in the IoT industry. Two broad categories. You have consumer IoT, you have industrial IoT. Consumer IoT is mostly about home automation and wearables, things like that. Again, probably more closely associated with personal things, right? And then you have industrial IoT, which involve major things like smart cities, connected car applications, smart grids, utilities, energy, transportation, so on and so forth. Many vertical industries are ripe for innovation, right, using industrial IoT technologies. For consumer IoT, it's fundamentally about connectivity and cost. Those are the big factors there. For industrial IoT, you have to worry about a lot more things. You have to make sure that your devices are very robust. They have to be able to operate in harsh environments with a limited or no intervention. They have to have a long battery life, and they have to deal with things like interference, which would be a big deal if you're using IoT devices to deliver and make decisions about energy distribution. You can't afford these devices to fail. So robustness, longevity, and operating in harsh environments, those are factors that become more important in industrial applications. So some examples of many vertical industries, right? And many of you probably represent these industries today. Most of the growth initially probably is going to come from smart buildings, both residential and enterprise. So here are things where you would install a carbon monoxide detector, maybe a temperature detector, more efficient lighting. Those are type of the early applications that we're seeing and are likely to dominate. And then you're going to get to more advanced applications like connected car. Just thinking about autonomous driving and connected car is intriguing. I mean, Singapore last year, towards the end of last year, they deployed some self-driving vehicles on their roads, right? So it's not that far-fetched. You think about how one vehicle can communicate with another vehicle, and for safety and better traffic management, vehicles communicating with the infrastructure for telematics, journey mapping, toll collection, merchandising on the go, lots of things, right? Lots of interesting applications, and IoT is going to play a major, major role. Wherever there is process, right, and if some process step can be taken out by deploying these sensor networks, these devices, that's an opportunity that's ripe for IoT. So before we get into the details, it's important to understand the architecture of an IoT system. When we talk about IoT, it's really not about a device. You know, you can talk about a smartphone as a device, but when you're talking about IoT, it's really a network, and it's trying to solve a business problem. So let's kind of look at the architecture of what the IoT value chain looks like. So you have these things, these sensors, these devices that's measuring some real world things, right? It could be temperature, it could be moisture, it could be direction, it could be anything, right? And many applications like we talked about. Using some short range communications, they talk to this next layer, the gateway layer, right? And then the gateways use some long haul communication mechanisms like cellular to communicate with the cloud. So all of the data gets to the cloud. Then you deploy machine learning, artificial intelligence, data analytics, and other software processing that happens in the cloud to deliver insights back to the business. So that's sort of how it works. And now you can pretty much map many of the industries in different places. So if you're a device maker, chipset maker, you're probably over here. If you're a software company, you're probably over here. And if you're an end-to-end player, like a consulting company like IBM, you might be deploying the whole network, working with many partners to deliver business insights and value. So this is sort of how it works. No matter what you do in the IoT value chain, you kind of need to know what this big picture looks like, right? Many, many different technologies. That's the other aspect about IoT. It's just not one thing. It's many things, and there are many applications. You have YSUN for smart meter readings. You have NFC for payments. You have Zigbee or Thread for home automation. So many applications. One size doesn't fit all. That's the other thing to remember. It introduces some challenges in one aspect, but it also is not force-fitting any technology for every application. So the players have plenty of choices, and the creativity lies in figuring out what's your application, what's your value, what's your business model, and selecting the right wireless technology for deployment. And the beauty of these many technologies is some of them operate in unlicensed spectrum. Some of them operate in licensed spectrum, like NB-IoT operates in licensed spectrum. But then there are many applications like Wi-Fi and other low-power wide area technologies that operate in unlicensed spectrum. So regulations are lower there. But if you're using something like NB-IoT, then you have to worry about a regulation. Some technologies are bursty, low data rate, and long range. In other applications are high data rate, high power consumption, and short range. So again, many different choices you have. It all depends on what you're trying to do. Is it a smart building that you're trying to design an IoT network for? Or is it a utility company wanting to do meter readings and get some insights so that they can regulate their power generation and distribution? So you have to kind of know what your application is and then how the whole network works to make your choices. This is just a short summary, and there's probably flyers out at the Keysight booth outside that talks about this in more detail. I think approximately there are 75 or more IoT wireless technologies. Now, not all of them are popular or widely used, but you can see that there are so many technologies and there are many different applications. The key thing that's enabling this is access to radio technology is becoming, the entry barrier to radio technology is becoming lower and lower. So whenever there's some spectrum available, you can make silicon like that that can just do the transmission. You can create these sensors, and you can take advantage of the spectrum, right? So that's what's creating this proliferation of formats. Over time, I think we'll see some of these settle out, and there may be some dominant technologies that are widely used. Okay, so what I want to talk about here is really talk about the business value. At the end of the day, you have to make money, right? And there has to be value that gets created and value that gets captured. And right now, that's a question mark, right, when you look at various aspects of IoT. So here's an idea on how we see value being created and delivered in this industry. You think about IoT. What is the real value? What is the piece that's of value there? It's data, right? It's data. The sensor is collecting some real-world data, and data is what is valuable to the business. Now, why is it different from smartphones? So in smartphones, data is almost viewed as a commodity. Yeah, you're listening to music, you're watching YouTube videos and things like that. It's all data, but you don't value that data too much. You're not willing to pay too much for those data contracts. Today, an operator makes maybe $5 US, give or take, per gigabyte of data, right? And we're unwilling to pay for more than that. So the data needs are going up, the infrastructure costs of the operators are going up, but they're not getting any return. But and we talked about why, because it's there to provide productivity to an individual user. Whereas when you think about IoT, you may have a tracking application. A pet might be very important to you. And I heard some examples earlier that in Hong Kong, one of my colleagues talked about this commute to the last mile is getting difficult, right? I mean, you have good public transportation, and that last mile commute is very difficult getting to your home. And then you have bicycles that they put in these train stations that you can pick up and then go, ride to your home. You can drop it off, and everything is tracked centrally. That's a great IoT application, right? So those types of IoT applications, you might be willing to pay more. If you're into agriculture, would you not want to know as a farmer what the moisture content is on a real-time basis? Or if your cattle is coming down with something, what is the health situation of your livestock? Those kinds of things. Those are important. And the point is, they're not very data hungry. So if you have a tracking application, you can probably do with 100 kilobytes of data per month. So you can probably consume on a per device basis just 1 megabyte of data for an entire year of valuable information, and you might be willing to pay $1 for 1 megabyte, right? So that seems reasonable. Per device, $1 for 1 megabyte for 1 year. That seems very reasonable. So all of a sudden, what's happened is the operators now for these types of applications get $1 for 1 megabyte compared to a smartphone contract where they can only get $5 for 1 gigabyte. So that's exactly why these IoT technologies and applications are appealing to operators, and that's probably how the business model is going to work, right? So that's the key point, is the value is in the data, and the applications define how critical that data is, and the cloud processing. This is why you see a lot of cloud analytics and software analytics process that data and give you valuable insights. To me, as a business owner, makes good sense and helps me make good decisions. So that's how the IoT value chain is going to get monetized. Okay, now that's enough of big picture. So let's talk about where we fit and how we help, and the details of the devices and the wireless technology and the challenges associated with that. So from a business point of view, challenges are threefold. Time to market, because you think about 75, 80 different technologies, all evolving at a rapid pace. So for a device maker to track all of that and create something of value and delivering it before the next evolution comes is a big challenge. So time to market is a big challenge. The other thing is you cannot, like I said before, treat it like one device. So I see many young faces here. Many of us may not have been alive in the 1960s, but back then you had vacuum tube diodes and transistors, right? But then in the 70s, thousands of those got put inside a system on chip or a linear IC. So the way you view a linear IC and the way you test a linear IC is very different from the way you view and test a diode or a transistor, a discrete device. So that's exactly what's going on with IoT. With IoT, you cannot think of anything as a single device. You have to think of it as a network, a connected network. And you have to think about testing, your business model, everything of that complete network. So product ownership cost becomes very important, right? Because you have to manage it like you're managing a network and not an individual device. And finally, we talked about what the business is, what the application is, and how you're going to extract and deliver value. So those are the challenges from a business side. From a technical side, it's power consumption, right? Many of these devices, a provider might have to enter into an agreement where they will not have the ability to replace these devices, replace batteries on these devices for 7, 10 years. So power consumption is a very big deal, right? Devices just cannot get firmware updates, because every time you get a firmware update, you're going to consume more battery. You cannot be checking with the network, am I okay, are you okay, are we, you cannot have too much communication between the device and the gateways and the access points. So how that's all orchestrated has an impact on power consumption. So power consumption, minimizing power consumption, the current draw is a big challenge for IoT device makers. Then you have the radio part. The radio is no less challenging than your cell phone. You still have to have good RF design on these devices, because if you have poor RF design, you know that devices can spend a lot of power just draining the battery trying to locate signals. So that's a big deal. Also, these devices are not nicely enclosed like a smartphone with good industrial design, and we also put covers on our phones and things like that. We take good care of our personal devices. These IoT devices are going to get installed wherever, on rooftops, on riverbeds, on mountaintops, in the soil, anywhere, right? So the enclosures that protect these devices may be good, may not be good, and your RF still has to work through all of that. Also, in many cases, these devices get included as one element of many other radio technologies. So even when you look at a cell phone, you've got many radio technologies all working together. So you have to make sure that there is minimal interference, and if you do that, you're going to become a good citizen from a device point of view, but you also reduce battery drain. We talked about these devices are not personal devices. They're going to be out there somewhere. However, they still connect to your network, your corporate network, home network, whatever, right? So security becomes a big deal. You're not protecting these devices. They're not inside your premises, but still they have access to your network. So security is a big challenge. And you cannot be doing antivirus, anti-malware updates to these devices on a regular basis, because that again drains battery. So the way you think about security on these devices have to be very different. And finally, on technologies like NB-IoT, which operate in the licensed spectrum, operators and the network providers are going to want to have you pass certification tests and their own tests before they can deploy the devices on the network. So many technical challenges that a device maker has to overcome to make a good IoT device. So we'll talk about each of these challenges. If you take a simple block diagram of an IoT device, this is what it looks like. So you've got a source, a power source, a battery. You've got a microcontroller, and you have a sensor that's actually measuring the real physical thing. And that gets converted into RF, and then out, it goes out through the antenna. So that's a very simplified block diagram of an IoT device. Now, what are the things that you need to worry about and test? So for battery, you're going to have to test how long it lasts, how much current draw there is, and so forth. On the sensor side, you need to make sure that whatever is measured is preserved, and that piece of information is modulated onto the RF section. So any crosstalk, any interference, any power spikes, things like that will compromise the integrity of the information that you're trying to transmit from the sensor. So that becomes a big deal. Then you have the radio section, the antenna section, the RF section. It needs to be efficient. It needs to cover multiple modulation formats, whether it's NFC or Bluetooth or Thread, whatever it is, you need to support that. And finally, you have these kind of questions. Is this device, when it's deployed in a network of other devices, is it being a good citizen? Am I sending out unwanted signals? How immune am I to other signals that come and hit me? Things like that you need to worry about, okay? So we'll talk about solutions that we have that addresses each of these challenges. So the first challenge, like I said, is power consumption. IoT devices are not sending or receiving information all the time, right? They are bursty. So they wake up, think of a water meter. They wake up, send some tens of bytes, hundreds of bytes of information, and then go idle for 24 hours and wake up again. So there is a big switch between active states and idle states. And the active state is very small compared to the idle state. So you have to make sure that you're able to make measurements across different operating modes. And the idling state, the current draw might be extremely low. And during the active state, you're going to draw a lot of current and use your battery. So as a device designer, you need the right tools to make these measurements across the different operating modes of the device. And here's an example of how stark that difference could be, right? Here, if you look at Bluetooth, during its idle state, it's only taking 100 nanoamperes of current, whereas cellular, when it's transmitting, is maybe more than an ampere, a couple of amperes, right? So that's a big ratio that you have to deal with. It's almost 10 million is to 1, right? So if you need, as a designer, if you need a test tool that measures idle states, active states, you should be able to cover that whole range. You need those types of tools. So that's something that we do. Today we might even have something in the stand to do this demonstration. So we provide solutions for the IoT industry, for the IoT device designers to help model this current and power draw, okay? And you have a variety of solutions based on performance and cost. So there are some really interesting software that goes on top of that that allows you to model across the various dynamic states. The second challenge, we talked about the RF and the wireless modulation. Again, if you're a device designer, you're not only making NFC devices. Maybe you're dealing with many different wireless modulation formats as a device maker. It doesn't make sense for you to just have one tester for NFC and another tester for cellular and another tester for Bluetooth and so forth. So you're looking for comprehensive solutions that can cover many different modulation formats for different phases of the product life cycle. So that's something that we offer. The third challenge, like I discussed, is the integrity of the sensor. The sensor, after capturing the real-world data, it needs to preserve that data and then modulate it on the RF signal. These devices are extremely tiny, right? In some sense, you can say they're as complicated as cellular phones or other types of devices, and probably in some sense more complicated because of the miniaturization. So the traces are extremely close, and you have to worry about crosstalk and interference. And you also have to worry about these tight interconnects. So a little bit of mismatch, and the signal will suffer many reflections, and you get into signal integrity issues. You want it to transmit a particular symbol, you're going to transmit a different symbol, and that data integrity is compromised. So that becomes a big challenge. We offer different solutions for addressing that challenge as well. Our network analyzer product family, as well as our scope product family, addresses some of the challenge. And I talked about some of the other challenges, being a good citizen, being immune to interfering signals, and also not causing interference. So you need to have EMI, EMC compliance solutions, so we offer that. And then finally, things like NB-IoT, where there is a conformance regime, there are regulations that you need to follow and adhere to. You need to have a proper conformance solution that we provide as well. So that's what, just to pull it all together, different challenges in in building an IoT device, and each of these challenges are amply covered by our solution portfolio. So no discussion on IoT, I would say, is complete without talking about 5G, right? Many of you probably are going to be involved in 5G as well to some extent. So if you're familiar with 5G, one of the key tenets of 5G is massive machine-type communications. So billions and billions of sensors talking to each other without any interference from human beings, and just going about conducting businesses and business processes. NB-IoT, we believe, is actually one of those technologies that could aid in massive machine-type communications and could be a precursor of a 5G technology. NB-IoT is standardized. It's part of 3GPP. And there's a lot of backing of NB-IoT from the operators. And it's also a technology that is efficient and leverages the existing infrastructure. So NB-IoT is probably where IoT and 5G intersect. The other thing I'd say is security. Security is a big deal in IoT. This is going to mushroom into a huge industry on its own. Like I said, devices are outside of your premises, and you really need to build security in rather than rely on security updates on your device. I'll talk about connected car, and then I'll have to close. I've got the people talking about the time factor here. Connected car is one area where many of the IoT technologies intersect, right? A car itself has many, many sensors, and almost all of the wireless technologies exist in a car. Not in your home, not in your cell phone. Everything from Bluetooth to cellular to GPS to, in the future, V2X and V2I would be Wi-Fi based technologies. So connected car is a great application for IoT. And the challenges it brings in are pretty significant. Not only there is congestion in your car, but many millions of cars traveling, and being able to coordinate and apply IoT technologies is a big deal. So watch this space. When you think about IoT, think about security, think about connected car, right? And there are lots of vulnerabilities because your car has many of these sensors. So you have to think about advanced testing techniques to simulate these attacks on your car and on the sensors of your car for things to operate normally. So we do provide solutions for that. So that's an example of how many attack points there could be on a connected car of the future, and you need solutions for that. Okay, so I want to kind of summarize saying that with IoT, you're really looking at taking process out. Every industry that has process in it will be addressed with IoT devices, right? Delivering crucial piece of data with analytics so that the right business insights are delivered. Many challenges exist from a device designer perspective, and we offer a complete portfolio of solutions to address those challenges. And the new domains of IoT will take you into a security domain and this connected car domain. Those are going to be leading applications of the future for IoT. And from a Keysight point of view, we cover the whole portfolio. If you're interested in knowing more, please visit us at this website or outside. I really want to thank all of you for this opportunity. And if there is time, I can take one or two questions. I appreciate it, and I hope this presentation was useful. Thank you.
Thank you, Mr. Kailash. So any questions for Mr. Kailash that you can raise right now?
Yes, sir.
There are too many technology in the IoT, something like narrowband IoT and CP and something like that. And which technology would be popular in the future?
Yes.
Yes.
Yeah, it's a interesting question, and it's a difficult one to answer. Like I said, the market is fragmented, right? Which is normal when a new industry takes off, when a new technology space takes off. There will be proliferation of many technologies. In the case of IoT, there are applications where you can use a certain technology and not worry about others. So because of the diversity in the applications and diversity in the many vertical industries, you will see more technologies than like cellular. Cellular will get standardized on LTE, right? I mean, you go from 2G, 3G, 4G, you can say, okay, it's all going to get standardized on one. No WiMAX, things like that. But in the case of IoT, I think because of the diversity of applications in the vertical industries, you will have many technologies. It may not be as many as as exists today. Today it's just starting, so everybody's making a proposal, but it will consolidate in a few years' time. NB-IoT is a good technology. I'm not endorsing any technology in any way. We remain agnostic from a company perspective, but you have to see what technologies have ecosystem support. And technologies like NB-IoT have ecosystem support. You know, operators are interested in it. Today's base stations can just be used to deploy NB-IoT with a firmware upgrade, and it leverages the LTE spectrum. So there are advantages to those technologies. So NB-IoT, I'm sure Cat-M, NB-IoT, Cat-0, Cat-1, those technologies probably have more legs, especially when it comes to operating in the licensed spectrum. When it comes to unlicensed spectrum and short range, then it's really up to you. Home automation will probably use Zigbee, Thread, but you could also use other technologies over there. You use NFC for payments. You can see that when it's operating in the unlicensed spectrum and the coverage is limited, you don't have that many regulations. It really is up to an economic choice, right? So I expect maybe not as many technologies as exist today, but still more technologies because of the diversity of applications.